Hi, good morning everyone. My name is Madhuri Prabhakar Shegavkar. I am MSc second year, Department of Chemistry. Content Introduction Steps involved in ICP-AES, Instrumentation of ICP-AES, ICP Torch, Diagram, and Applications. Introduction Inductively coupled plasma atomic emission spectroscopy is one of the several techniques available in analytical atomic spectroscopy. ICP-AES utilizes a plasma and the atomization and excitation source. Plasma is an electrically neutral, highly ionized gas that consists of ions, electrons, and atoms. The sunlights and sunlights are the example of plasma found in nature. The energy that maintenance and analytical plasma is derived from an electric or magnetic field. They do not burn. Most analytical plasma operates with pure argon or helium, which makes combustion possible. Plasma are characterized by their temperature as well as electrons and ion density. Analytical plasma typically range in temperature from 600 to 8000 K. As a comparison, the temperature of the sun interior is millions of degrees, while the steps involved in the determining the chemical constant of an aqueous phase sample by ICP-AES. Steps involved in ICP-AES. Sample preparation. Some samples require special preparation steps including the treatment with acid, heating, and microwave digestion. Number second, nebulization. Liquid converted to aerosol. Step 3. Volatilization. Water is driven off and remaining solids or liquid portions are converted to gases. Step 4. Atomization. Gas phase bonds are broken and only atoms are present. Plasma temperature and inert chemical environment are important at this stage. Excitation and emission. From gain energy from collision and emit light of a characteristic wavelength. Separation or detection. A getting dispersed light that is quantitatively measured. Instrumentation of ICP-AES. Nebulizer, pumps, spray chamber, sample eject, ICP torch, RF generator and detector shown in the figure. ICP torch. The ICP is radio frequency 27.12 MHz, 40 MHz. Introduce plasma that used are the introduction coil to produce a magnetic field. ICP operates between one of the 5 kilowatt. The introduction coil is wrapped or three times around ICP torch. Has water flow through for its cooling purposes. ICPs have a capacitor bank that is continuously turned to match the plasma inductance in order for the RF to travel along the surface of the below coil with minimum resistance. The coil is either gold or silver plated. Neither gold or silver forms metal oxides upon contact with air. Although the RG power supply maintains the plasma, Tesla coil is used to ignite the plasma through the generation electrons and ions that couple with the magnetic field. The most common ICP torch is used today has evolved over decades of the development. The circular quartet has 12 to 30 mmOD, has three separator glass inlets. Only one glass routine uses argon. The glass enters the plasma through the outer channels with the tangential flow pattern at the rate of 80 to 20 minute per inverse pattern. The nebulizer gas has the laminar flow pattern and eject the sample into the plasma. The analytical zone is approximately 1 centimeter above the coil and offers the best optical viewing area for maximum sensitivity. The plasma temperature is the analytical zone ranges from the 5000 to 800 K. The temperature vary with power, flow rate, etc. The high temperature assure the most samples are commonly atomized through some molecular species. Examples N2, OH, C2, etc. do exist and can be readily measured in the plasma. Applications of ICP-AES. The analysis of considered by simplified with the ICP-AES technique. On an average, radio frequencies work on 1 to 12 kilovolts, while plasma argon flows at the rate of 12 to 15 kilo per minute. Usually traces of metals like Cu, Fe, Mg, Mn, Cd, Zn, and other from the waste analyzed by Icp-Ase. ICP techniques can be used analyze from blood, Cu in brain tissue, Ase in liver, Na in breast milk. Trace metals from alloy and steel are also analyzed metals such as Cu, Fe, etc. from lubricant oils and gasolines can be analyzed by the trace concentration. ICP-AS can also be used employed for the analysis of agricultural products and foods. The Earth sequence lanthanides in the rocks can be analyzed in environmental analysis of Fe, Cu, Cd, Nn, Zn from sea waters are easily analyzed. Thank you.